Let us try to obtain the Fourier series for the function f of x in where f of x is defined like this. It is equal to 1 in between the values minus pi and 0, and it is equal to 0 in the interval 0 and pi over minus pi comma pi. We know that solution for this is like this. We know that f of x is equal to a0 by 2 plus summation an into cos nx, where the value of n ranges from 1 to infinity, plus summation bn into sin nx, where the value of n ranges from 1 to infinity. Wait. A0 is given by the relation. You observe this, the interval is in between minus pi and pi. If it is in between a to a plus 2l, then we say that it is of length 2l and l is equal to, that is l is said to be the length of the interval. Here in place of l, pi is present, therefore I write my 1 by pi integral minus pi to pi f of x into dx. Okay. Now you can able to write this as 1 by pi integral minus pi to pi in place of f of x. You observe this, the value of f of x is defined like this. I cannot write a single value in between minus pi and plus pi. It is, I define in two ways, that is in between minus pi to 0, I write this as 1 into dx, and in between the interval 0 to pi, I write this as 2 times dx. Is it okay now? Now I write this as 1 by pi times. Now you observe this. What is integration of 1 with respect to x? And 1 with respect to x means I write x in between the limits minus pi to 0 plus 2x, that is 2 is constant. Again integration of 1 with respect to x is x in between the limit 0 to pi. Now I write this as 1 by pi into, in place of x, if I write the upper limit 0, it is 0 will be minus of lower limit, that is minus pi. Is it okay? Plus 2 times. Now I write the upper limit, that is pi, minus the lower limit, it is 0. Now I simplify the things. This is equal to 1 by pi into minus is plus pi plus 2 pi. Therefore, it is equal to 1 by pi into pi plus 2 pi is 3 pi. That is pi present in the denominator goes with the pi present in the numerator. Therefore, we are getting the value of a0 as 3. Is it okay? Now, in order to write this Fourier series, I need to calculate an. Now, I write this an as is equal to 1 by pi times integral minus pi to pi f of x into cos nx into dx. Okay, now I write like this. Now again, for the same reason, I split this integral into two parts, that is from minus pi to 0 and 0 to pi. In minus pi to 0, the value of f of x is 1. As I told you already, it is 1 into cos nx into dx plus integral 0 to pi. In this interval, the value of f of x is 2 into cos nx into dx. Okay. Now Now I simplify the things. This is equal to 1 by pi times. What is the integration of cos nx? Integration of cos nx is sin nx divided by n in between the limits minus pi to 0 plus 2 times again the integration of cos nx is sin nx divided by n in between the limits 0 to pi. Is it okay? Now I write this as 1 by pi times. If I am substituting x is equal to 0, it is sin 0. Sin 0 is nothing but 0 minus. If I am substituting sin of n into pi, that is sin of minus n pi. Sin of minus n pi is plus sin n pi. Sin n pi value is 0. Okay? Plus 2 times. Again for the same reason, 2 times sin of n pi is 0. And sin of 0 is 0. Therefore, since if you want, you write like this. What is that? Sin n pi is equal to 0, which is equal to sin 0. And sin of minus n pi is equal to minus sin n pi, which is equal to 0. Okay? For this reason. Now, I am getting the value of an as how much? It is equal to 0. Here I am getting the value of a naught as 3 and an is equal to 0. Now I want to find out the value of bn now. Bn is equal to 1 by pi times the integral minus pi to pi f of x. What is that? It is f of x into sin n pi x by L means sin n pi x by pi, that is sin nx into dx, which is equal to 1 by pi into. Again for the same reason, I split the integral into 2 parts. One is from minus pi to 0. In that interval, the value of f of x is 1. Therefore, I write 1 here into sin nx into dx plus 0 to pi. In this interval, the value of f of x is 2. It is sin nx into dx. Now you integrate this. I write this value of 1 by pi is constant. Therefore, I write that as it is. 1 into sin nx is 1 is constant. Sin nx is 1 into sin nx is sin nx only. Integration of sin nx is minus cos nx by n in between the limits minus pi to 0 plus 2 is constant. Therefore, I write this outside the integral sign. And integration of sin nx is again it is minus cos nx divided by n in between the limits 0 to pi. Now I write this as 1 by pi. Now I write the upper limit where x is present. I substitute x is equal to 0. In this, it is minus cos 0. Minus cos 0 means it is minus 1 by n. Okay. Minus into minus will become plus lower limit. And this is cos n pi divided by n. Okay. Plus into minus is minus 2 by n. If you want, you write like this. It is I am taking minus sign as the common factor and I write substitute x is equal to 0. Therefore, I get this result. Here I am taking n is the common factor and it is minus. I am taking minus sign as the common factor. Is okay. I am writing this as cos n pi minus cos. Now I simplify this. This is equal to 1 by pi times minus 1 by n. Minus into minus is plus. Cos n pi value is minus 1 whole to the power of n minus 2 by n times cos n pi means minus 1 whole to the power of n. Minus into minus is plus 2 by n. Okay. This is here minus into 1 by is minus 1. Now I write this as 1 by pi times. You observe this. Here it is minus 1 times 1 by n and it is 2 times 1 by n. Therefore, if I subtract, I am going to get 1 by n. It is minus 2 times minus 1 whole power n by n, and it is 1 times this. Minus 2 times plus 1 times means it is minus 1 time. It is minus 1 whole to the power of n by n. If I am taking 1 by n as the common factor like this, I write this as 1 minus of minus 1 whole power n. Okay. Now, Bn is equal to, I am getting Bn is equal to 1 over n by 1 minus of minus 1 whole power n. Now, f of x is equal to I am getting a naught by 2. I substitute the value there. It is a naught by 2 plus summation an into cos nx means an itself is 0. 0 into anything is 0. Okay. Plus summation bn means it is summation 1 over n pi into 1 minus of minus 1 whole to the power of n into sin nx. Here there is no necessity of writing this 0, but if you want, you write this. This is equal to summation 1 over n pi into 1 minus of minus 1 whole power n into sin nx. Okay, this is the way the value of n ranges from 1 to infinity. Now you observe, if I am substituting n is equal to 0 or 2 like this. If I am substituting n is equal to even number, this is going to be 1 minus 1. Therefore, it is going to be 0. When n is equal to even number, this value is going to be 0. Therefore, I write this as f of x is equal to 3 by 2 plus summation 1 over 2n minus 1. 2n minus 1. Here you can write this by outside the summation sign also, as it is free from n. n is equal to 1 to infinity. Here when n is an odd number, this minus 1 whole power odd number is minus, therefore 1 plus 1 is going to be 1 plus 1. Therefore, this is equal to 2 times sine of 2n minus 1x. Therefore, Therefore, I can conclude that f of x is equal to 3 by 2 plus, here you observe this 2 is constant, therefore I can able to write that 2 outside the summation sign, and it is 1 over 2n minus 1 into sine of 2n minus 1x, where the value of n ranges from 1 to infinity. This is the required Fourier series. I write that as Fs. Is it okay? Here, the only thing we need to remember is, here instead of finding the integral from minus pi to pi, I divide the integral into two parts because f of x is defined in different way in the interval minus pi to 0 and 0 to pi. Only that thing is to be recalled while integrating this, and here we need this in order to substitute those things. Okay, let us go for one in the interval minus pi comma pi. Is it okay? We know that octal, here the title is octal, the Fourier series for this function. We know that f of x is equal to a naught by 2 plus summation an into cos nx divided cos nx, where the value of n ranges from 1 to infinity, plus summation bn into sin nx, where the value of n ranges from 1 to infinity, where a naught is equal to 1 by pi integral minus pi to pi f of x into dx. Okay, and an is equal to 1 by pi integral minus pi to pi f of x into cos nx into dx, and bn is equal to 1 by pi integral minus pi to pi f of x into sin nx into dx. This, that is T.G.Mamatha RHS, is the Fourier series for this function. Okay. But when we look at the integration between minus pi to pi, I know that what is the integral minus a to a f of x into dx is equal to 2 times integral 0 to a f of x into dx if f of x is even. If f of x is even. What is even? If f of x is an even function, actually is an even function. Okay. Now, instead of integrating between minus pi to pi, it will reduce to 0 to a f of x into dx if it is an even function. I know that one. Okay. Therefore, I try to check for whether this function f of x is equal to x square is even or not. F of x is equal to x square. If I consider f of minus x, that is, if I replace x by minus x, this is going to be minus x whole square, which is nothing but x square. X square is nothing but f of x. Therefore, f of x is equal to x square is an even function. Is an even function. Is it okay? If it is an even function, the note on that Fourier series, while discussing about the Fourier series, we say that if it is an even function, Pn is going to be 0 and only a0 and an. If we calculate a0 and an, it is a0. We discussed like that. Therefore, if it is an even function, this indicates that Pn is equal to 0. Okay. Now, I try to find out the value of a0, which is equal to 1 by pi times. Instead of writing, as it is an even function, instead of writing minus pi to pi, I write 2 by pi integral 0 to pi f of x into dx means x square into dx. Now I write this is equal to 2 by pi times integral 0 to pi. That is very small. That is integration of x square is x cube by 3 in between the limits 0 to pi. Therefore, your a0 is equal to 2 by pi into pi cube divided by 3 minus, if I am substituting x is equal to 0, 0 by anything is 0. Therefore, your a0 is equal to 2 times pi square by. Is it okay? Now I write an is equal to, again for the same reason, instead of considering the integral between minus pi to pi, I write here, you observe this, f of x is an even function and cos of x is also an even function. Even into even function is even. Therefore, again I can use that result, that is 2 by pi times integral 0 to pi x square cos nx into dx. This is the value of a. Now I will write the reason for this. Is it okay? Here g of x is equal to x square cos nx. That is the term inside this integration is, I write this as g of x. It is x square cos nx. If I write g of minus x, this is equal to minus x whole square into cos n into minus x. I know that cos of minus n theta is cos n theta only. Therefore, I write this as x square cos nx, which is equal to g of x. Therefore, g of x is an even function. You observe this, I call this x square into cos nx as g of x. Okay, in order to verify whether it is an even function or not. Now I write an is equal to, in order to integrate this, I use the technique of integration by parts. Is it okay? I write 2 by pi constant. Now I write the first term. What is that? X square. What is integration of cos nx? This is equal to sin nx by n minus. Now I write the differentiation of x square. It is 2x. Next I write the integration of this term. If you want, you write this 1 by n as the common factor, or else you can write like this one. What is sin nx is minus cos nx by n square plus differentiation of this 2x is 2 and integration of this is minus sin nx divided by n cube in between the limits 0 to pi. If I am substituting the value of x is equal to pi, that is the upper limit in this, we will get, you observe this will become sin n pi into pi square. Sin n pi value is 0, therefore it is 0. If I am applying the lower limit for this term, it is again 0. Minus 2 pi, minus into minus is plus 2 pi into cos n pi divided by n square. Again, I am substituting the value of lower limit. Lower limit means x is equal to 0. 0 into anything is 0. Therefore, I write this term. That is the value of this is equal to that much. Next, I write plus 2 into sin n pi value is 0. Sin 0 value is also 0. Therefore, I write this much. Therefore, I am going to get an as 2 pi times 2 pi into cos n pi value is minus 1 whole to the power of n divided by n square. You observe this pi goes with this pi, and your an value is equal to 2 into 2 is 4 into minus 1 whole to the power of n divided by n square. We are having the value of A naught, we are having the value of An, and we are having the value of Bn. Now we can able to substitute those values in f of x in order to get the Fourier series. Is it okay? Now I write f of x. It is 2 pi square by 3 divided by 2 means I write this as 1 by 2 plus a summation an. It is 4 into minus 1 whole to the power of n by n square into cos nx, where the value of n ranges from 1 to infinity. I am not writing this bn. Since bn value is 0, 0 into anything is 0. If we add 0 to this term, it will not alter, it will remain as it is now. Therefore, I write f of x is equal to pi square by 3 plus summation 4 into minus 1 whole to the power of n by n square into cos nx, where the value of n ranges from 1 to infinity. RHS is the here RHS means the term on RHS is the required Fourier series for the given function. Is it okay? Now